Alright guys, we're going to look at adding and subtracting decimals. Adding and subtracting decimals. And this is in your textbook. This is Chapter 3, Section 3, if you need to go back and look at more examples. We're going to do a couple adding examples, a couple subtracting examples, and then we'll do one where we're solving an expression with a variable. So we'll start off with example 1. We're using graph paper because when we're adding and subtracting, one of the most important things you can do is to line up your numbers by the decimal point, using the decimal point. So let's say we're going to add 3 and 26 thousandths plus 4 and 7 tenths plus 1 and 38 hundredths. So what we're going to need to do is make sure that we line up each of these numbers with the decimal points all in the same place. So I put my first number here. My second number, I'm putting it in the exact same order with the decimals, and then my third number. Now you also know that when we are adding and subtracting, we might have these gaps here. We want to fill those in with zeros just to make it all look nice and neat and even. But before we add them together, we want to estimate our decimals to see what our answer should be close to. So 3 and 26 thousandths is pretty close to 3. 4 and 7 tenths is close to 5. And 1 and 38 hundredths is pretty close to 1. So if we add those together, we find out that our answer should be somewhere around 9, or about 9. So now we can add them up exactly, bringing down our decimal point in our answer. And when we add this up, we should get 9 and 106 thousandths. Now that's very close to 9, so we know that this answer is reasonable. Let's look at another one. Let's say we're going to add 84 hundredths plus 2 and 9 tenths plus 3 and 52 hundredths. So like we did before, we want to line these up using our decimal point. And then we want to make sure to fill any gaps with zeros. And before we add them together, we're going to estimate. 84 hundredths is pretty close to 1. 2 and 9 tenths is very close to 3, and 3 and 52 hundredths is pretty close to 4. If we add those together, we should see that our answer should be around 8. So if we add it up, 4 plus 2 is 6, 8 and 9 is 17, plus 5 is 22. And then we'll be left with 7 and 26 hundredths. And that's pretty close to 8. Now let's look at some subtracting examples. So we're going to subtract 78 minus 74 and 9 tenths. Now one thing I notice is that this number 78 does not have a decimal written next to it or in it anywhere. But we know that with any whole number, the decimal is always going to fall right behind it. So when we want to line up these numbers, we know that the decimal point in 78 would just be right here. So then we can line up 74 and 9 tenths underneath it, making sure we fill in any gaps with zeros. This is especially important when we're subtracting. Like we did before, we're going to estimate. 78 is already estimated. It's an exact whole number. 74 and 9 tenths is really close to 75. And if we subtract those, our answer should be somewhere around 3. Now we know we can't take 9 from 0, so I'm going to have to borrow from the 8. 8 will become a 7. The 0 will turn into a 10. 10 minus 9 is 1. We have to bring down our decimal. 7 minus 4 is 3. 7 minus 7 is 0, so we don't have to write anything there. And we can see 3 1/10 is very close to 3, so that answer is very reasonable. Okay, let's look at one more for subtracting decimals. Let's say we're going to subtract 50 minus 7 and 86 hundredths. 50 minus 7 and 86 hundredths. Now you might notice this one is pretty similar to the last one in that we don't have a decimal in this whole number. This is just 50. But we know that with any whole number, the decimal is going to just go directly to the right. So when we line them up, we're going to have 50, and this is where our decimal point would go. So then we can line up 7 and 86 hundredths underneath. And we need to make sure to fill in those gaps with zeros. And again, before we subtract, we want to estimate. 50 is already estimated to 50. 7 and 86 hundredths is really close to 8. And when we subtract, we would be left with 42. So our answer should be close to 42. Now we've got to subtract. Now we can't take numbers from 0, so we're going to have to start all the way on the left and do quite a bit of regrouping, but you should know how to do that. So 10 minus 6 is 4. 9 minus 8 is 1. Bring down your decimal point. 9 minus 7 is 2. 4 minus 0 would give us 4. So our answer, 42 and 14 hundredths, is very close to 42. So that is definitely reasonable. Now the last thing we're going to look at is evaluating an expression. And we know that an expression is just an equation without an equal sign, but it's going to have a variable in it, and a variable is just a letter. So this expression, we're going to have 9 and 67 hundredths minus x. Now we can't solve this unless we know what x is. So this is telling us that x is equal to 1 and 52 hundredths. So your directions will tell you something like, solve the expression when x is equal to 1 and 52 hundredths. So we know to solve an expression, you take whatever x is supposed to be equal to, and you plug it in. So instead of 9 and 67 hundredths minus x, we're going to have 9 and 67 hundredths minus what x stands for, 1 and 52 hundredths. Now that looks like something we can solve. So we're going to line up our numbers using our decimal point. 9 and 67 hundredths minus 1 and 52 hundredths. Before we subtract, we're going to estimate or round. 9 and 67 hundredths is pretty close to 10. 1 and 52 hundredths is closer to 2 than it is to 1. So if we subtract, we find out that our answer should be somewhere around 8. So we'll go back. 7 minus 2 is 5. 6 minus 5 is 1. Bring down your decimal. 9 minus 1 is 8. And 8 and 15 hundredths is very close to 8, so our answer is reasonable.